today the idea is to guide you through a different angle on vector search and RAG. So basically the idea is to understand how it's possible to use also vector search and RAG on mobile. Basically, the idea is that AI is creating a lot of opportunity also on mobile, because clearly now a lot of interaction on mobile. And another important aspect is about latency. So we want applications that are fast with low latency and that are clearly reacting very well to our input and to our context. So we will see how to use this kind of boost for our application. Clearly it's a complex environment. So for instance, you can see here that there is a really huge explosion of tools and different models, framework in the generative AI space. For instance, these are the tools that are available in LangChain framework. You have a lot of different models, open source or closed source to use. You have different kind of document loaders, different kind of vector databases that can be like specialized vector database, but also general purpose database like Couchbase. So it's a very broad and fast evolving ecosystem. Let's start with some basic. I believe you are familiar with the vector concept, so I won't spend much time on these, but clearly the idea is that a vector is just a list of numbers. It's easy to visualize it in a bidimensional space. We are all familiar with latitude and longitude for coordinates, with RGB model for representing color. And clearly, when we have a multi-dimension vector like an embedding vector return from, for instance, OpenAI model, it's much more complex to visualize in the space, but clearly it's just a matter of having a list of numbers representing clearly semantic meaning of that particular text, image, video, or something else. The idea, in particular with databases, is the fact that for computers, it's easy to calculate distance between vectors. So it's very easy also for us to understand the concept of distance in a bidimensional space, clearly, because if I am here in these coordinates, I can see that the most close point is A, clearly it's easy. And the same concept applies to multidimensional vectors. So the same things is the thing that we can easily calculate the distance between one vector representing a text or something else and other vectors to find meaningful vectors that are similar to what I'm searching for. So with these, we can solve different kind of use cases. We can use GenAI to do content generation. For instance, imagine like the summary of reviews that you already have on Amazon. It's generated by GenAI. You can do, and we will see the example in the demo later in the code, data classification. So basically you can, for instance, classify images based on similarity. You can do clearly semantic search, which is kind of more advanced than classic text-based search, clearly. And we have seen today a lot of example on the enhancement you can have in chatbots, clearly leveraging on this kind of technology. Just to give you an example related to data, clearly the idea is that you have your images, your text, you use an embedding model, and then you load the vector inside the database, which is very efficient also in indexing them. So clearly having efficient indexes, with that you can do queries. And basically you transform the input, the text or the image in a vector and search for the for the nearest neighbors. So the vectors that are closest to my input, to my query. So it's like we have seen before, a very simple mathematical calculation, easy for the computation power we have now, not only with GPUs and very powerful compute unit, but also mobile, because now they are very powerful also on device. This is a classical reference architecture for RAG. I won't spend much time on this because we have seen a lot of examples today, but clearly the idea is to have a database, a vector database that acts as a vector store. So the idea is to have something which is efficient in storing vectors and also efficient in searching for the nearest neighbor thanks to an efficient indexing system. So I will pass the query, I will get out basically the nearest vectors to my input. Intrinsic concept is about vector search towards full text search. The point is that some databases like Couchbase supports both. So you can also like mix different kind of search. You can do classical full text search based on terms. So it's not a semantic search, it's not based on the meaning of the words, it's just to find similar words. And clearly vector search is a sort of game changer because it refers semantically to what I'm searching for. The idea is that in some use cases it's also good to combine these two kind of different search. Okay, just to give you a brief overview of Couchbase, it's a NoSQL database, document-based, so it supports JSON. The idea is that with Couchbase you don't have to have a specific vector database that does only vector search, but you can use Couchbase as a general purpose database, and on top of that have also the feature of vector search in your cloud environment, for instance, but also on mobile, as we will see later. Clearly, one important point in this case, in general, with vector databases is about the ecosystem integration. So clearly, also Couchbase integrates with the most used framework in this space, like, for instance, LangChain and Llama Index. How does it work? As I was saying before, it is based on JSON. So clearly, your data model is just a JSON file. So it's a text, basically, that consists of different fields. And the idea is that you have one specific field that represents a vector. You could also have multiple fields representing vectors. So basically, you could also use different embedding models inside a single JSON and do different queries leveraging on different embedding models. Then the idea is clearly that you can index efficiently the vectors. So we have an indexes engine that efficiently stores the vectors to look for the nearest neighbor. And as I was saying before, the idea is also that you can combine different type of queries, full text search, but also using SQL to do like classical SQL query in which I want to search for instance, shoes that have size 11, but also I want to order them based on the results of my vector search. So it's very flexible because you can combine different types of queries. Okay, so having said that, let's have a look on specific capabilities on mobile, which is kind of peculiar for Couchbase because it's basically a NoSQL database, JSON-based, that in the case of the mobile platform runs directly in a device. So the idea is to have a full-fledged NoSQL database, document-oriented on device, and also we have the capability to synchronize the data between the device and your, I would say, central database. So the idea is to have an application which is in a kind of offline-first approach, so that can read, write data locally on device, but then has also the capability to synchronize data with your central environment. And you can also have a kind of flexible architecture. For instance, you could have multi-tier architecture and have the embedded database on your devices, synchronized on an edge data center. For instance, we have one use case in which the central data center is a ship in the sea, and clearly all the data are synchronized on a ship. which is a kind of edge data center, and then clearly from all the ships around the world, all the data are synchronized into a centralized cloud database. Okay, so why is it important to run vector search on mobile? Well, the first point is about the possibility to do that also in offline mode, when your application is completely isolated without any internet connection. So the idea is to use it with a clearly not so powerful model like you have in the cloud, but basically a model that can run directly on device, and you could do that directly on device without requiring any internet connectivity. Also, it's a matter of cost, because clearly if you use proprietary model, they cost, or you are billed for each call, but also clearly it's a matter of bandwidth consumption, because every time you want to call an embedding model in the cloud, clearly the cost also in terms of networking. And clearly this improves latency because it's running directly on your application. Last point is about privacy. Clearly, sometimes, but this is a general, I would say, consideration, sometimes you don't want that some data leaves your device because you want them to remain private on your device. For instance, you can think of use cases in healthcare. Sometimes you want that data related to your health remains local and don't want to store that in the cloud. Okay, the idea is more or less to have the same concept of RAG, but on the device. So basically, in this case, the embedding model will be on device, and all the database processing will remain on device, because Couchbase Lite, Couchbase Mobile provides basically an embedded database, JSON-based that runs on device. So it has the capability to store the vectors on the local database, and also clearly to efficiently index them, and clearly to query them. Okay, having give you this brief introduction, hope is clear. The idea is to show you also some code with a very simple demo. So let me switch to the code. Okay. Basically, this is a very simple Android application. In order to use Couchbase Lite, you need to add some libraries, clearly. One is Couchbase Lite itself, and the other one is basically the vector search support, which is not shipped by default, but is like an add-on if you want to use vector search. So basically, I specified, as you can see, Couchbase Lite and the vector search add-on. Okay, so this is the main entry point in the database management on device. So basically, the idea is to use Couchbase library to create an embedded database that runs directly on my application. And also I need to enable the vector search add-on. When I initialize my database, basically the idea is to run this function, import data from JSON, and with that, I'm just loading some images, preloaded images on which I already calculated the embeddings. So these are very simple images with an on which I use a very simple embedding model, which is called AlexNet. And basically, I fill up my application at the start with these, I would say, preloaded data, in order to have different kind of images with their embeddings, with their categories. So basically, the images are divided into categories. One is shapes and one is like Lego characters. So this is the idea. The idea is then to use the application to classify the images. So based on an image I will upload, I will vectorize it with my simple embedding model, and based on the vector search query, I will return the most similar image, and based on that, I will have the category of my image. As you can see, I just wanted to show you this function. The search function is basically, as you can see, a very simple query in which I will pass the vector as an input, so the result of the embedding of the uploaded image. I will search for the nearest vector, so the nearest image which is more similar to my input. So that's the idea. It's very simple, but the idea is that just to show you how I can run it directly on a device without involving anything external. Okay, so last thing is about clearly this function, when I upload an image, the idea is just to call the embedding model, which returns a simple vector of 3 dimensions, and based on that, run the query. Okay, let me show you if it is working. I hope so. So basically, if I run my application, it will initialize the database locally, and will also load the embeddings I already preloaded in order to have some images with the proper category. So, and the idea, the last point is that then based on the category, I will propose 2 different types of quizzes. So if it is shapes, a quiz about shapes. If it is a Lego character, it's about Lego character. So the idea is just to show you how to simply categorize images based on vector search. Okay, so I hope you can see. Okay, basically running my application, I created the local database. I have also some vector stores because I pre-uploaded the embeddings. And then if I upload an image, for instance, I will go for my circle. I called a very simple embedding model, which is called AlexNet. Based on that, I retrieve the vector, so the embedding for this image, and you can see the result of the query. Basically, with my query that I show because that simple SQL query, I had as a result this image and the corresponding vector, which is the nearest one. Based on that, I can say that this image is a shape. So this is a simple categorization use case. Based on that, then it's a shape, and then I will have my quiz based on the shapes clearly. So it was just a simple example to show you how I can use it locally on the device. If you want, you can also try it. It's on GitHub, so basically you can go and grab it from GitHub and have a look at how it works. Clearly, maybe AlexNet is not the best model to categorize images. It's very simple, but clearly you can play with it and use different models. Because one important point is that we are agnostic in terms of embedding, so you can use the embedding model you prefer. We ask just the vector part and efficient storage for vectors and indexes. Okay, yeah, also the important point is about the possibility to do hybrid search. Imagine you want to search for a shoe which is similar in color to an image of your car. So basically you can upload the image of the car and say, I want shoes with that color, but also with other predicates, which are not vector search in this case. So classic query predicates, it wants price in a certain range, I want ratings in a certain range. So it's very easy to combine different types of queries and to develop a very interesting application based on that. Finally, yeah, the idea is that with Couchbase you can basically have vector search, classic vector search as a vector database in the cloud, in whatever environment you prefer, but also combine it with edge mobile capability, so you can run this kind of application directly on devices and on edge use cases. That's it on my side. Thank you.